Hello and welcome to today's training class. We'll be focusing on ANSYS and what transfers over. Things like spot welds, instances, mid-surfaces, shared topology, materials, named selections, and beams. The first thing we'll look at today are spot welds. And the first thing we'll do is open up a file. We'll be opening up our spot weld file inside of our ANSYS class folder. And we'll be applying some spot welds between these parts. You can see spot welds is located under the Prepare tab. But the first thing we'll do so we can see the spot welds better, so I'm going to select these two solids, go to Display, and make them transparent. This will allow us to see better where and when I'm applying these spot welds. We'll click on the spot weld button and get started. Now the first thing we'll want to do is select on the bottom surface to apply the spot weld. And notice you can select through the geometry by scrolling the mouse wheel forward. Now once we've selected that as the base face, we'll select the edge to apply the spot weld on. Notice we'll get a few displays that pop up which allow you to control the count, the edge offset, and the start and finish offset. You can edit any of these boxes, or you could type them into the options panel on the left side of the screen. It's sometimes easier to use the options panel because they're all arranged there vertically. And going back to the tool guides, if you want to select another face, you'll notice that you can do that and select another edge. And the same spot weld will be applied to the other edge as well. And when you're finished, click the Complete button and a spot weld will appear in the structure tree. Now let's apply another spot weld here. So just like before, we'll click the face and then choose the edge we'd like the spot weld on. And notice that SpaceClaim will automatically detect faces nearby even if they're not touching. And our third tool guide will allow you to select the mating face. So we could choose the bottom, or we could choose the yellow face here. So we can determine which face we'd like our spot welds applied to. Remember, spot welds will control which nodes will be sharing when it passes over into ANSYS. Notice these gray nodes in the middle don't have a mating one, so they will not be transferred over. Only nodes with mates will transfer. Now let's apply one more spot weld here. We'll select on the face, and I can double click to get the tangent edges to apply the weld to. Now one thing we might want to do is change some of our properties. So let's change these from 2 to 0. And also we can increase the number of points in the spot weld. Changing this from 8 to 16 or 32. And the more spot welds we have, the closer it will be in an analysis to a seam weld. So this is one of the ways you can approximate a seam weld in SpaceClaim. Now that we have these three welds, we'll click our ANSYS button and transfer the geometry over. Now here we can zoom in and we can see some of the spot welds and how they're located as connections. And you can see this a little bit better once we mesh the model. So here are all the connections, all those spot welds that have transferred over. And if you click on them, you can see where they are on the model. Now let's go back to our mesh, and you'll notice that every place a spot weld is on the part, you'll see there'll be a point or a node there where the mesh meets up. So I hope you've seen how you can apply spot welds in SpaceClaim and have them transfer over. Next we'll look at instances. So we have our model with all of our spot welds still applied. And we're going to start to create some instances in our SpaceClaim model. Select on Component 1 and we'll move it to the left about 12 millimeters. Notice how the spot welds stay applied as we do this. Now let's move it back in the other direction, but hold Control down as we do this. That will make a copy of the component. Notice that we have two component ones in the structure tree. And also you'll notice if we rename one of them, they both rename. These are copies of each other, and anything you do to one component will be affected in the other. This is essentially an instance in SpaceClaim. That's one way we can do this, and another common way to do it in SpaceClaim is to select a part and click the Create Pattern button under the Move options. Now when we drag this solid up, we'll create a copy of it. And also we can enter a count and turn that into a pattern. And just like before, if you edit one of our pattern members, they'll all update. One thing to also look at with this is that we'll change all of our IDs of the part when we do this. So you'll probably want to detect the mating faces again from any spot welds that are there. Notice that we were able to find spot welds on multiple faces. So again, if we'd like to go back and have a little bit more control over this, we can click our spot weld tool, click on that spot weld. We can change the properties to anything we like to edit it further, or using that same tool guide, we can select a new face. Now once we have all of our spot welds applied and we have all of our instances, let's pass this back into ANSYS 12. So here we can see the geometry as it comes in. And one of the benefits of having instances in ANSYS are that they'll all be meshed the same, so it'll save some time with meshing. But also it makes it easier for selection. You'll also see that there's another selection filter you can use when grabbing these parts. So if we zoom in, we can see that all of these meshes are the same. If I click on one face, you'll notice I can extend to instances. And one thing you'll also notice is that only the top 4 solids are instances and the bottom one is not. And that's because when spot welds are applied to the solid, you'll notice that they'll have a different mesh because of that. So they won't be detected as instances, which can sometimes be a problem. Notice if we look at the mesh on the bottom of these faces, our spot welds are on the left, and there's no spot welds on the right. Another way to check to see if they're instances are to go into your worksheet and check the number of nodes for each solid, or for the different components that we're working with. But once we've made any of these changes, let's go back and show the solid. I want to show you how you can apply the same spot welds to the parts so they are identified as instances. So now let's reapply another spot weld here, where we can select our 2 faces. Remember to scroll through the model by rolling the middle mouse wheel, and then select the 2 edges. Now it's crucial that you don't just apply any spot weld, but that the 2 spot welds are exactly the same. So we'll type in our numbers for our first spot weld, 2, 2, 2 for the offsets, and 8 for the count, and create the spot weld. Now when we go back to ANSYS, we can refresh the geometry, and that will pass in any changes we made in SpaceClaim back to our ANSYS part. Now you'll notice I can click on a face and extend to instances. I hope you've seen how instances can really save some time in the meshing process. Next we'll look at mid-surfacing. And mid-surfacing can be done a few different ways in SpaceClaim. And we'll start by opening up another part. And the first thing we'll do is go to our Prepare tab. It's where we prepare geometry for analysis. And we'll click on our mid-surface button. Notice that there's a lot of mid-surfacing options you can use. And we'll start by using face pairs. Notice if I click on one face, it'll only filter in faces that are parallel to it. You can see it'll identify all of them with the same thickness, or also that are within the thickness tolerance. If you'd like to add faces to it, click the Add Face tool guide and add the face. notice you only need to add faces to one side of the model. And when you click Complete, you'll see a representation of the mid-surface through the part. And once you click in white space or change tools, it will automatically hide the solid you're working on. So now we can see we have our mid-surface generated. And also notice in the Properties panel, you'll have that thickness applied to all of those faces. So that's one way we can make mid-surfaces in SpaceClaim. I'll open up our mid-surfacing SC doc to see another way. So let's click back on our mid-surfacing tool. And now again, we can use face pairs if we'd like. And we can notice that only parallel faces are included. We'll select on the face behind it. And now we can add faces to our selection. Just by selecting more faces, they'll be added to our filter. So now we have all of these different rib thicknesses in the part. And once we have all of them, notice we can offset or swap the face pairs by changing the green to blue. And this doesn't need to be done all the time. It just helps control which side the normals are facing when passing over to ANSYS. And once you've swapped any faces you'd like, you can go through and create the geometry for the model. Notice our create options here, which control whether it's created in the same component or the active component. So we'll be creating the active component. So even though this solid is located inside of the parts component, notice the mid-surface component is made at the top level. We'll undo and click the same component, and notice that when we create it this time, that mid-surfacing component will be inside of part. So if we expand that, we can see it here. And also notice that we have our mid-surfaces, and we'll undo back and show you a third way. And this time we'll use a range. So you can see we have our minimum and maximum thicknesses that we'll search for, and we'll just click the solid. This will identify all of the faces that fall in that thickness range. And also notice that I'm going to turn Group Mid-Surface off and turn it to the active component. Now when I create our mid-surface, notice that nothing is created inside of their own component, and everything's automatically made at the top level. And one thing to look at again, if I go to select on these faces, how our mid-surface thicknesses are applied in the Properties panel. And we'll go to ANSYS and pass these over. Once here, you'll notice by selecting on some of the geometry that we're working with, these properties, these thickness properties, are also passed over. So that's one way we can share and pass information between the two systems. And also when I mesh this model, we can see how all of our faces show that thickness. And this is an option in ANSYS which you can control on whether you want to display the thickness or not. But I've hoped you've seen in this short little class how we can create mid-surfaces through naming selections, and also through searching for an entire body. An important thing to look at between SpaceClaim and ANSYS is using shared topology. And this will come up quite often when you want to create a multi-body part to get really nice meshes between them. So the first two things we need to look at with shared topology are the components that the solids are located in. And you can see the property here under the Properties panel for shared topology that needs to be set to true in order to use it. And also, only solids in a single component will share. So if you want these mid-surfaces to share, you'll need to set them from false to true. You can see how there's two surfaces in there. So there's two surfaces in each component will share, and these solids at the top level will all share. Now another thing I'd like to point out is that you don't need to imprint any edges on any of the parts. This will automatically be done when we transfer the geometry over to ANSYS. And we'll do that by going to our Prepare tab and sending it over. Now here I've already started meshing the part, and it's just finishing up. Now if we go to the connections, we can see that there's not really any connections that are there. And here if we select on these faces, we can see where some of them are sharing topology. Another easy way to see this is if I hide this solid in the middle. You can see that these faces have been split where they're sharing between them. So you can share between solids, you can share between surfaces, and you can share between line bodies and surfaces. Now I'm going to take this bearing and I'm going to move it to a new component. Now this component, now that I've changed it, will update the geometry. This will no longer share topology between the rest of them because I've placed it in its own component and told it to not share. So there's no way it's going to share with any other solids that are there. And we'll see this better when I mesh all of our components again. So once it finishes up, we'll zoom in and we'll hide that bearing component. And notice that these faces are no longer split. So the two important things to remember when trying to share topology are that all the solids in a component are capable of being shared, and they will only share if you change the option from false to true. The next thing we'll look at is materials. So we still have this model open, and let's look at how we can pass materials into ANSYS. Select on one of the solids and go to the Properties panel. Here you'll see you have a number of different properties you can select on. And choose aluminum. Notice that we have a lot of properties applied to the different values. The three key ones are thermal conductivity, elastic modulus, and also the density. Once these three are applied, you'll be able to pass it into ANSYS. Select on the top two solids and apply a different property. We'll apply gray cast iron. You can see here that not all of these properties are filled out. We only have density and we don't have elastic modulus or thermal conductivity. So this material will not transfer over. You'll get whatever default property you have set in ANSYS. But you can also create materials from scratch. We can call this dense rubber. We'll apply a density to it. And now we can apply an elastic modulus to it as well. And to do that, you'll want to expand elastic modulus and type in a value. You can either type in a number or type in an expression to represent that. So we'll type in 6.23 times e to the 6. And we'll also add a thermal conductivity. So we'll only input these three values, and once we have them, that's the minimum amount we need to pass the geometry over. Or pass the materials over, I should say. So now we'll click on our button to transfer to ANSYS. And another thing I'd like to point out is in your geometry options, make sure you have material property set. This will also be located under Tools, Options, Geometry Options. Material properties has to be set to true. Now we can start the analysis and pass the geometry over again. Now once here, if we expand our Geometry tab in the Structure tree, you'll be able to select on them and see the different materials that are there. So you see that some of them will default to structural steel, while others we can have dense rubber, or if we click on our bearing, it's set to aluminum. So I hope you've seen how we can transfer materials into ANSYS by having our three key ones applied: density, elastic modulus, and thermal conductivity. Driving dimensions and named selections are important for passing parameters and named selections into ANSYS. We'll open up our keychain model and take a look at this. So let's zoom in to the right of the yellow part and go to our Groups panel. This is where we'll create our named selections and driving dimensions. So let's select on these two cylindrical faces and create a group. You can see that a name selection will appear there. You can select on as many faces as you'd like and create a named selection. And by clicking on them, you can rename them. So we'll rename these Cylinder, and we'll also rename this Support, so we can identify them easier when we pass them over. Now let's select on this round and look at the properties. Rounds will have a property value associated with them. So when I create a group now, we'll create a driving dimension. That's a parameter I'll be able to control inside of ANSYS. Another way to know if you'll create a driving dimension is if you see a value on screen with the pull tool when I select on a cylinder. This will also be a driving dimension I can control inside of ANSYS. If I just select on this face with pull though and create a group, you'll notice that we'll only create a named selection. It's because there's no value in the Properties panel or on screen. However, if I create a ruler dimension to the other side and now create a group, that will be a group that I can control inside of ANSYS as a parameter. Now let's rename some of these groups and then check them out inside of ANSYS. Once they're renamed, remember to go back to the Prepare tab and click on the ANSYS add-on to send the geometry over. Now it's also important, just like materials, that you turn name selections and parameters on. And also if there's any name selection or parameter key that you're using, either make sure they have that in Space Claim or remove them. Now we can see our different name selections that we've set up. And if you use them, you can select that and use that as a boundary condition. And also, if we select on our geometry, we'll see the CAD parameters that we've placed on our part. So we can place these parameters on DUM, STEP, or IGES files, or on geometry that you create from scratch in Space Claim. Now once we get in our parameter manager, you can change some of these values. And once we update our project, we'll be able to see the changes reflected in our Space Claim model and also in our ANSYS model. So we'll go over to Space Claim and see how these have changed here. Notice they've changed inside of our Groups panel, and they've also updated inside of ANSYS. Now another thing we'll look at is using annotations to create driving dimensions. So let's show this plane that has several different dimensions on it. Now one way we can do this is by placing them from the Detailing tab, and that's how we can create these annotation dimensions. But you'll notice that if I move some parts, the annotations will update in real time. Now that won't really help us make a group. You'll need to click on a direction and click on any of these sparks that are shown. Once we do that, we can use it to control the part and update it, or when I create a group, that annotation dimension will be the same as creating a ruler dimension like I did with the pull tool. And this new parameter, this new driving dimension, will show up once I refresh our geometry. So that will take any geometry we've changed in Space Claim and add it to our part. So we'll click on Geometry, and notice I now have 4 different options. And also a key thing to look at is our length and our component length are the same thing. but this is how you can make two different parameters that control two different aspects. Changing our length will only change the face that we are pulling on, but changing our component length will change where the component is located. So hope you've seen name selections and driving dimensions and how they can be applied in ANSYS. Another key thing with SpaceClaim is extracting beams from solids. And the first thing we'll do is open up our part, which will be located inside of the beams folder. And we'll open up Truss System. Here we can see we have a lot of different components with solids located in them. Now the way we can extract these beams are to go to the Prepare tab. We'll zoom in a little bit and we'll click on the Extract button. Now by clicking on any of these solids, we'll extract the beam profiles and also the beam elements from them. And we can see this a little bit better if we show the solid beams, or we can show the wire beams. And also notice the beams folder and also the beam profiles that are created. And notice each profile is associated with one of the beams. Now one of the fastest way to extract beams are to box select all the beams you'd like to extract. Notice we've created a lot more in the structure tree, and again we can show the solids or the wires. Now one key thing to look at when extracting all of these beams are that sometimes you'll need to extend them if they don't meet each other. So to do this, click our Extend tool to the left of the Prepare tab. And definitely switch the option so it can detect some of the distances between them. So if I increase to 15, you'll notice that all of these points are 15 centimeters or less away from each other. And if all of these haven't been fixed, increase the size of your search and you'll find more. So we've increased this to 55. Now you can box select areas and fix them by hitting Enter, or click the checkbox to fix all of the ones you can. And also if we zoom in, we'll see that all of these really aren't together to one point. And that's determined by how the solids are initially created. So to manually change these beams, you can move the points of them. You can move them to a new location, or snap an endpoint up to another location. And we can do this by using our Maintain Connectivity option in the Move tool. So that's a manual way you can change all of these beam endpoints. And once you're ready, we'll transfer it over to ANSYS. A key thing to look at when transferring is that your import options have to be set to None or to Line Body. And now we can transfer geometry in and get to work on it. Now one reason you'll want to extend all of these beams is going back to a previous part of this class, which is shared topology. Beams will only share topology with each other if they're extended to each other. And also one thing I didn't do here was change our option under the component to share topology. So even though these will be extended to each other, they won't share topology because I haven't set that option. And one thing that we can also look at is our mesh. Notice that our line bodies are now shown in ANSYS with some of the thicknesses associated with them. So here I hope you've seen how SpaceClaim can be used to extract solid bodies from these parts. And also remember, if you'd like them to share topology, definitely change our shared option from false to true. Another workflow for beams are to create them on curves or on edges of a solid. So let's open up our Create Beams SCDoc, where I've placed some 3D curves in the model. So now we'll look at our profiles. And if we click on the down arrow, we'll see some of the different profiles we can choose from. We'll choose the I-beam. And when we do that, notice that a beam profile has been created in the structure tree. And if we click the Create button, we can now create a beam on one of those curves. Let's change to solid display so we can see these as they're created. Clicking on the different curves will create them on those curves. And if we'd like, I'll place one of our profiles there, but now let's add a T-beam. And notice by clicking on that I-beam, it will switch. So you can switch beams just by creating a new beam on that curve. And a faster way to do this would be to box select or manually select these curves and then click the Create button. Doing that will create a beam on all of the selected lines. Another key thing to look at with our profiles is that you can right-click and edit those beam profiles. And to do this, you can use some of the pre-established groups that we've made in any of these files. Click on the groups and change the value. We'll change them from 0.1 to 0.2. Another way we can make changes to these profiles are to manually change them, such as selecting the Move or Pull tool and dragging to change on these profiles. And also, remember you can use the ruler option to precisely set the changes. And coming back to our Create Beams, we can see how all of our beam profiles have updated. Now another thing to look at will be our Orient button. Orient will control the orientation of the beams. So this is one way you can change the angle the beam's displayed. And notice you can also look at the property as it changes in our property panel. So you can either manually rotate the model to make a change, or we can edit the orientation inside of our properties. We can also control where they're placed, whether it's the location, the area centroid, or the shear center. Also notice by dragging our beams off the line, we can change where they're represented in space. Where the actual beam is located, the faceted model, that's where the beam will locate in space, and the wireframe is then only used for shared topology between the beams. So I hope you've seen and learned a lot about beams, spot welds, mid-surfacing, name selections, and all of our other tools we use to transfer as much data as we can from SpaceClaim into ANSYS. If there are any questions, please contact support@spaceclaim.com. Thank you for watching.